Hello everyone, I am Siddharth Kumar Jha and today I am going to talk about data pre-processing and EDA, which stand for like exploratory data analysis. Okay, so before understanding the EDA and pre-processing, first we have to understand what is data. Okay, so data is nothing but the raw material of the machine learning. So in the most real world database are messy and they contain missing values, outliers, inconsistencies, and irrelevant features. So if we have directly feed such data into model, so the result will be misleading or completely wrong. So that's why we spend a significant portion of the project on the data pre-processing and exploratory data analysis, which is EDA. So pre-processing ensures the data is clean, consistent, and suitable for modeling, while EDA helps understanding the pattern and relationship in the data. So together, they form the foundation of successful data science. Okay, so I hope I'm clear with the introduction part, like what is EDA, what is data, and what is pre-processing. So let's discuss it one by one. So the next one is like what is the importance of data cleaning? So data cleaning is a vital in machine learning as it improves the data quality, removes noise, and handles missing value, as I already discussed. So clean data ensure accuracy, consistency, and efficiency, and leading to better model performance without cleaning models and risk bias, error, and poor predictions. So simply put, quality input guarantee reliable, faster, and a smarter output. Okay, so let's move into the notepad and understand it in detail. Okay, so let me open my notepad now. Okay, so in the notepad also let me make the topic name, which is like data processing and exploratory data analysis, which is EDA. Okay, so let's talk about the definition part. So let me write it down. So data cleaning. Uh, is the process of detecting and correcting inaccurate records, removing inconsistencies, and ensuring the dataset is usable. Okay, so this is like data cleaning. So, like, let's talk about like why it's important. So, imagine a hospital data set where some patient blood pressure and regarding are missing or wrongly recorded. So, you have a hospital database and you have some patient blood records which are missing or wrongly recorded. So it would be a model without cleaning it, might recommend the wrong treatment or life-threatening. Okay. So similarly in business, wrong data can lead to poor decision and final loss. Okay. So the common issue in the raw data is the common issue in raw data. So what are the issue? The first one is like duplication. Second one is like inconsistencies. Third one is like typographical errors. And the fourth one is irrelevant data. And the last one is missing value. So let's talk about one by one. So duplicate means like some record are entered multiple times. Okay. So some records entered multiple times. So suppose, for example, like customer name is Siddharth and it appears twice. So this leads to the duplication. Okay. So the second one is like inconsistency. So let me write it here and explain. Inconsistency. So inconsistency means like different formats for the same information. So what it means, like for suppose an example, there is one column, gender column. Okay, so it has the value like M or male, okay, or F or female. So in this, there are the different format of the same data is present. Okay, so this is called the inconsistent data. I hope I am clear. So the next one is third one is a typographical error. Typographical errors. So what it is basically? So spelling mistakes or wrong entries. You can say like spelling mistakes or you can say wrong entries. For example, suppose in your data set, the India is written, okay? So India. So it is written like INDAI. So there is some spelling mistake here. Spelling mistake. So this is called as the typographical error. So moving further, for the fourth one, which is irrelevant data. Data. So what it is basically the features that do not contribute to the prediction. It's called like irrelevant data. So suppose for an example, there is a you are making a model which can predict the which can predict like a person should approve their loan or not. Okay. So in this, the favorite color of the person is not mandatory, but in your data set, it is also mentioned, like what is the favorite color of the person and whether the person should approve their loan and not. So in that data, this doesn't make any sense. So this is called the irrelevant data. So the next one is the last one, which is missing values. So as the name suggests, unfilled or null entries. Okay. So suppose example, salary column missing for some employee. Like there is the employee exists, but there should be some salary, but in the data set, the salary column is like null. Okay. So this is called the missing value. So let's talk about the process of data cleaning. So the next topic, which is process of data cleaning. So there is three steps basically. So step one is your detect error. Step two is your like correct error, and step three is your validate. Okay, so let's understand these all three steps. So the first one is like detect error. So it is using descriptive statistics or null check or duplicates. Okay, and the correct error means like replace or impute or remove. Okay, so in the correction of error, you are like replacing the value or imputing something or either removing that thing. Okay, so the next one is like validate. So validate means ensure the data makes sense. Okay, as I have told you in this example, like whether a person should approve their loan or not, we have one features like the person favorite color. So it is not useful, I think, for predicting the model like the person should approve a loan or not. So this is the second one, and the last one is like last one validate also only. Like the what are the data set that should make some sense. Okay. So there is one key point. Just write it down for your reference. Key point. It is like without data cleaning, even the best algorithm, even the best algorithm will fail. Okay. So I hope the process of data cleaning is clear. So let's moving further, which is like handling the missing data and outliers. Handling handling missing data and outlier. So the first one is like the missing data. Missing data. So the reasons why data is missing. So first understand that. So reason why data is missing. So it can be because of human errors, human errors, like skip from fields. Okay. And the next one is like faulty sensors, and it can be like data corruption. Data corruption during the transfer. Okay, so these are the reason like why data is missing. So what are the technique to handle the missing values? So now we'll discuss that. So the technique to handle missing value. So the first technique is like deletion. Second one is imputation, and the third one is a special placeholder. So for all the three, let's discuss it one by one. So the first one we have talked like deletion. So deletion means like remove rows with missing values if they are few and not critical. Okay, like in this there is one this like loss of valuable data. Okay, so the second one which we have discussed is imputation. So the imputation means filling values. Okay, so for that there are three. Which one is? Let me write it down. The first one is like mean, median, and mode imputation. Second one is like forward and backward fill. Okay, and the third one is like predictive imputation. So in the imputation, there are three types. First is like a statistic, like mean, median, mode. Second one is like forward and backward fill, and the third one is like predictive imputation. So, like in the mean, median mode, if the age is missing, replace it with the average age or the median age. Okay, I hope this is very simple to do. And the next one is like forward and backward fill if outlier exists. Okay. No, no, no. In the mean and median, like median is better if the outlier exists in the data. Oh, sorry. Let me write it down. Median is better when outlier exists. Okay. And the next one is like forward and backward fill. So fill missing value with the previous or the next available values. Okay, so the third one is like predictive imputation. So predictive imputation means like use regression or KNN to estimate the missing values. Okay, so the third one is spatial placeholder. Spatial. placeholders. So in this, we are filling with unknown for categorical or minus 9 triple nine for numerical. So it is useful when missing itself has a meaning. Okay. So I hope I am clear with the missing data. So the next one is like outliers. So now we will discuss the outliers. So let's understand what is outlier first. So an outlier, oh sorry, an outlier is an extreme observation that deviate significantly from other data points. Okay, so outlier means an extreme observation that deviates significantly from the other data points. For example, suppose average monthly income of a data in a data set is 40,000, but suddenly the record shows like 9 lakhs. So there we can understand like there is some outliers. Okay. So the next point which we will discuss, which is problems caused by outliers. Problem caused by outliers. So the first problem, which is skew, average, like mean. Average is mean. The second one is like mislead models, like regression. And the third one is like may represent, it may represent rare but important cases like fraud detection. I hope I am clear like what are the problem caused by the outliers. So let's discuss like what are the methods to detect the outliers. So moving further to the next page. So in this we will discuss like methods to detect outliers. So the first one is like visualization. So in the visualization we can do box plot, scatter plot, etc. Okay. And the second one is like Z-score method. So Z-score method means let's take an example and understand. So if Z is greater than 3 or less than minus 3, it is a outlier. It is outlier. So the formula for Z-score is something like Z is equal to X minus mu by sigma. I hope I am clear with the formula. So moving further, like handling outliers. The next topic is handling outliers. So if there is error, remove it. If genuine but extreme, transform transform it either in the log or square root, and if important, like fraud case or rare disease, so what you have to do, keep them. So this is how we are handling the outliers. So now the third portion is like encoding categorical data. Okay, so let me write down encoding categorical data. Okay, so the problem, just understand one problem and then we will discuss it. So the problem is like most ML models cannot handle text label directly. So they require numerical input. Okay, for example, suppose there is one table for gender and salary. So for the male and the female, the salary is 50K, 15,000, 50,000, and for the female, it's 60,000. Okay, so algorithm cannot process male and female. Okay, so encoding method like helps to understand like what is male and what is female. Like it convert it into the numerical format. Okay, for understanding to the model. I hope I am clear. So now we will see like what are the method of encoding. So encoding methods. So the first one is label encoding. Second one is one hot encoding. Third one is ordinal encoding. And the fourth one, which is the last one, is frequency or target encoding. Okay, so let's talk about first, which is label encoding. Okay, so first one is label encoding. So the label encoding assign the numericals or the numbers to the categories. For example, suppose there, let me go to the this. Let's suppose here the male and female is written, so it will assign like male for 0 and female for 1. So simple, but cannot create more value if there is given. Okay, so understand it first. So assign numbers to categories. For example, I have told you like male is equal to 0 or female is equal to 1. But simple, but this is simple, but can create false ordering. I hope I'm clear. So moving further, the second one, which is your one hot encoding. One hot encoding. So let's understand it, what it is. So it creates dummy variables. Okay. So it creates dummy variables. Okay. Suppose there is, for example, country. Country is there like India, USA, and Japan. Okay. So for India, it will create like 100, and for USA, it will create like 010, and for Japan, it will create like 001. Okay. But it avoid the order problem, but increase dimensionality. Okay. So this is called one hot encoding. So the next one is ordinal encoding. The third one, which is ordinal encoding. So let's discuss what it is. It is for the categorized with order. So suppose one example, education. Let me write down the example here. Example, education for the high school. You will write it like 1, and graduate, you will write it like 2, and postgraduate, you will write it like 3. So this is how there is one order on which you are assigning some numerical value. Okay. And the last one, which is the frequency or target encoding, or target encoding. Okay. So it replaces categories with their frequency or mean of the target variables. Okay. So let me write it down. So it replaces categories with their frequency or mean of target variable. I hope I'm clear. So for example, in a lone data set, job type replaced with the default rate. Okay, I hope I'm clear. So moving further, which is feature scaling and normalization. The next topic is feature scaling, and normalization. So let's understand first why scaling is required, and then we will understand one by one and the techniques. So the first one, like why scaling is required. So features may have very different range. Suppose, for example, the age can vary between 20 to 60, and salary can be vary from the 20,000 to the 1 lakh. Okay. So the distance-based algorithm like KNN or SVM will give more weight to the features with longer values for the salary. Okay. So the technique which we will use, so we will discuss all the techniques one by one. So the first technique which we are using is normalization. First technique which we are using is normalization. Okay. So what is normalization? It scales the feature to 0 to 1. Scales feature in the range of 0 to 1. Okay. So the formula for this is like x dash is equal to x minus xm divided by x minus x. Wait, sorry. The formula is little bit wrong. Let me correct it. So formula is like x minus mu divided by maximum of x minus minimum of x. Okay. This is the simple like what you can say representation. Okay. Uh, so this is all about the normalization. So it is based for natural networks, or you can say the neural network. It is based for neural networks. Okay. So moving further, the second which is standardization. Okay. So the second one is standardization. Standardization. So let's understand what it is. So in this we cells to mean 0 and a standard is equal to 1, like rescale to mean is equal to 0 and a standard is equal to 1. So the formula is x minus mu by sigma z is equal to. So and standardization means your z score scaling. You can call it like z score scaling. I hope this is clear. So moving further to the fifth topic, which is data visualization and EDA technique. Okay, so let's go to our slides and discuss it first, and then we will come to the notepad for the detailed explanation. Okay, so data visualization and EDA, which is exploratory data analysis, helps to understand data sets before modeling, and visualization user uses like graph. In the graph, you can say histograms, scatter plot, heat maps, and box plot, and there are so many graphs. So to reveal the trends and correlations and outliers. So EDA techniques include summary statistics, distribution checks, missing value analysis, and feature correlations. So together they uncover insights, guides feature selection, and improve ML model accuracy. Okay, so let's go to the writing pad and we will understand it in details. So here let me write down my topic name. So which is data visualization and EDA technique. Okay, so First, we will understand from the starting of the video. We are just listening what is EDA, EDA, EDA. So now we are going to uh, talk about EDA first. Okay. So what is EDA? What is EDA? So EDA means exploratory data analysis is the process of summarizing datasets and finding patterns, detecting anomalies, detecting anomalies, and testing hypothesis, testing hypothesis before modeling. So I hope I'm clear with that what is EDA. So let's discuss why it is important. So let me go to the next page, and now we will discuss like why EDA is important. So the first point, like it helps us to understand data structure and guides, features, engineering, and identifies hidden trends. Okay, so there is some steps which are involved in the EDA. So now we will discuss like steps in EDA. Steps in EDA. So the first step is like univariate analysis, like single variable. Okay. So for this, there is like histogram, bar plots, bar plot. So in histogram, it distribution of numbers value, distribution of numeric values, and in the bar plot, like frequency of categorical values. Okay. So example is like example as I have told you like histogram of age in population. If we have to find out the population age, so histogram can identify it very carefully. So the next one is in the steps of exploratory data analysis, which is bivariate analysis, bivariate analysis. So in this there is two variables. So for that there is one scatter plot and second one is box plot. So in the scatter plot, the relationship between two numeric variables, and in the box plot, we are like distribution of numeric across categories, distribution of numeric across categories. So I hope I am clear. So there is one more, which is correlation heat map. Correlation heat map. So in this, like check the relationship. Okay. So for example, suppose salary versus age. So this comes under the scatter plot because I told you like in the scatter plot, we are like defining the relationship between two numeric variables. Okay. So this is about the bivariate analysis. So in the last one, or you can say the third one, which is multivariate analysis, or you can say multiple variable. So the first one is like pair plot. So pair plot means scatters plot for many variables, scatters plot for many variables. And the second one is like principal component analysis, which is PCA for dimensionality reduction. Dimensionality reduction. Okay, so for example, there is one iris data set. So pair plot to visualize the flower species. Okay, so I hope I am clear. So now we will talk about the visualization tools which we have available. So let me go to the next page. Visualization tool. Visualization tools. So the first is like Python. So in Python, there is like many libraries like Matplotlib and Seaborn or Plotly. Okay, and in the BI tools, which is like Power BI and Tableau. Okay, so this is all about the today's video. So in this video, we have learned the most fundamental stage of data science, which is data pre-processing and exploratory data analysis. So we began by understanding the importance of data cleaning and why messy data leads to misleading results. And then we looked at how to handle the missing values and the outliers so that our data reflects reality more accurate. So we learned how to convert categorical data into numeric form using encoding techniques, make it usable for machine learning algorithm. So we discuss features scaling and normalization, ensuring that features with the larger range do not dominate other in our models. So finally, we explored EDA technique from unvariant to multivariant analysis and how visualization helps to uncover trends, pattern, and relationship hidden in the data. So this is all about the today's video. So thank you for watching the today video, and in the next video we will meet up with the new concept in the machine learning journey. So तब तक के लिए keep learning and keep exploring. Bye bye.